Here we have a nice little video to help us get ready for tomorrow about isolating variables. Remember, isolate means to get alone by itself, and so when we isolate a variable, we are solving for x, and so our end goal is to find out what x equals to isolate x. So for example, we're going to have 3x plus 12 equals 24. And so what I'm looking at here, excuse me, I'm looking for what is getting in my way of having x alone on one side of my equation. And what's getting in my way of having x alone? Well, first of all, I have this number 12. That's stopping me from having x alone. And I have this number 3. If I get rid of those two things, and I can get rid of so I can get rid of the 12, get rid of the 3, that tells me I have x alone on one side of my equation because I've got rid of those other two numbers. So when you're isolating, you're trying to get rid of those numbers. In our equation, it says 3x plus 12 equals 24. So 3 times some number plus 12 equals 24. So I need to start whittling away and trying to figure out how I can get rid of that 12 and how I can get rid of that 3. If my expression says to take 3 times x and then add 12, then I'm going to subtract 12 to get rid of it. Because if I can add 12 and equal 24, I just want to find out what 3 times x equals. So first of all, get rid of that 12. Whatever you do to one side of your equation, remember we got to balance it out, got to do the other side of the equation as well. So now what I have left over is I have 3 times x equals 12, because that was 24 minus 12. And so now I'm looking at this equation. Again, I don't have x alone. I don't have x isolated like I wanted to as my goal. And now it's saying 3 times x equals 12. So in order to get x alone, now if it's saying take 3 times x, again, I'm going to do the opposite. Just like up here, where it said take 3 times x plus 12, I subtracted 12 to get away. I did the opposite. It said add 12, so I subtracted. Here it says take 3 times x equals 12. So I'm going to divide by 3 on both sides, because I want to get x alone. If I take 3 divided by 3, that's just 1. 1 times x is still x. So now if I take 12, and I again have to divide it by 3, because whatever I do to one side of my equation, I have to do the other. So now I'm left over with these two cancel out, because that's just 1 times x, and that just equals x. Now I have 12 divided by 3, and that equals 4. So now my final equation is x equals 4. When I isolated my variable, x equals 12 divided by 3, and that turned me to 4. Let's look at one more. Now a little bit different type of problem. Here we see a subtraction sign. And so we have a little bit different problem, but right now I have 5 times x minus 7 equals 18. So 5 times something minus 7 equals 18. So again, trying to isolate for x. Again, my goal is to get x alone. And so again, stopping me from doing that, my 7 and my 5. If I get those two away, then in my whole entire equation, I should have x alone on one side, just like I'm looking for in my goal down here. So in order to do that, I have to start whittling away and start getting away with rid of those two numbers, that 5 and then that 7. Because those, like we said, are stopping me from having x alone. So if my equation says take 5 times x and subtract 7 to equal 18, I want to find out what just 5x equals, so I need to get rid of that 7. If it's saying subtract 7, I do the opposite, add 7 to get rid of it. Whatever you do to one side of your equation, you have to do the other. So now I'm taking 5x, that just gets brought down. If I was decreasing by 7 and now I'm adding 7, those cancel out, those are just 0. So now I would have 5x plus 0. And so I'm just going to leave it as 5x. And now I have 18 plus 7, which equals 25. Now my new equation is 5 times x equals 25. Again, this 5 is getting in my way of having x alone, so I need to get rid of it. I need to isolate it. I'm trying to get x by itself. So it's saying take 5 times x, and that equals 25. In order to get rid of that 5, I need to divide by 5. So I divide that by 5. Again, the opposite of multiply, because it says 5 times x equals 25. Divide by 5 and divide 25 by 5, because whatever you do on one side of the equation, you got to do the other. So now I have x left over because these two 5's cancel, and I have 25 divided by 5, and that equals 5. So my final equation, x equals 5. Our next problem is a little bit different. We're going to dip into some negative numbers. We got to remember all our rules about negative numbers. So again, I'm just looking at 15 minus 3x equals 3. Again, my goal to isolate x, get x by itself. So I'm looking at, I have a couple numbers getting in my way of doing that. This 15 is in my way, and this 3 is in my way of getting x alone on one side of my equation. So again, right now I have positive 15 minus 3 times x equals 3. I'm trying to get x alone, so I'm going to get rid of this 15 first. I have 15, I'm going to subtract 15 from each side. Now I have these two equal 0, so now I have, again, bring down my negative, negative 3x equals 3 minus 15 equals negative 12, because I'm starting at 3, decreasing by 15, so it takes me 3 spaces to get to 0, and I still have 12 spaces to go further. So now that takes me to negative 12. Now I have my equation is negative 3 times x equals negative 12. So I'm looking for some number times negative 3 that equals negative 12. In order to figure it out, again, negative 3 is getting in my way, so I need to divide by negative 3 on each side. So now I have x, again, this cancels out because negative 3 divided by negative 3 is just 1. Now I have x equals negative 12 divided by negative 3. A negative times a negative is always going to be a positive. And so now I have 12 divided by 3, and that equals 4. So here my x equals 4. All right, last problem we're going to look at is going to be a little bit different operations, but still, our main goal, isolate for x. Get x alone, get it involved, get it only on one side of your equation where it's just x. Again, looking back to the top, I have this negative 2 getting in my way of having x alone, and this divided by 4 getting in my way of having x alone. So I need to get rid of both of those two so that I can have x isolated. If I have x divided by 4 minus 2 equals 3, first I'm going to get rid of this 2. And it looks like I'm decreasing by 2 because we see that minus sign there. So I'm decreasing by 2. If I'm decreasing something by 2 and I want to get it back to 0, because remember our goal is to make that equal 0, I need to add 2. So again, that's going back on our theme. If it says subtract 2, do the opposite to get rid of it. So I'm going to add 2 to this side. Again, looking at my balance. When I add 2 to one side, I have to add 2 to the other. I'm going to rewrite my equation to see what's left over. Now I have x divided by 4 plus 0 equals 5. So now what I'm looking at is some number divided by 4 equals 5. Again, if I'm really not that certain on my division skills, I see that I have x divided by 4. Going back to that same theme, if it says x divided by 4, do the opposite to get rid of that 4. So it says divide by 4, I'm going to multiply by 4. And it says 5 times 4, or then I also have to take 5 times 4 because I have to balance out that equation. So if I have x divided by 4, and I'm going to multiply that by 4, and essentially that's 4 over 1, I get 4x over 4, where those 4's cancel out, and now I'm just left with x. And then I take 5 times 4, and that equals 20. So again, if it says divided by, I multiplied to get rid of the 4. If it said subtract, I added to get rid of it. Whatever the operation says, do the opposite in order to get rid of it. Remember, our goal is to isolate that x.